I think we're just about ready. Hey everyone, thanks for having me. Tonight, as mentioned earlier, I'm going to be talking about MVC. Sure, some of you have heard of it. So recently I was asked to help at a Rails Girls event. And some of the people there are completely new to code. Some of them have maybe never written code before and maybe didn't even know how web apps actually work. So when I was asked to explain the concept of MVC, I said, yeah, sure, I know what MVC is. In fact, I'm probably sure half of the people in this room know what MVC is. I'm relatively, confident of that. But how do you explain it to someone who doesn't know what MVC is? Let alone a room full of people who potentially don't know. Well, it turns out it's not as easy as you think. I went along to the event and I presented. I need to finish up looking out to a room full of blank faces staring back at me. So, hopefully that's not the case today. This is take 2. First up, what is MVC? Well, let me tell you. A couple of weeks ago, just after I opened the issue on GitHub to give this talk, someone luckily clarified it for me. Thank you very much. MVC stands for Model View Controller. I guess that solves the mystery, huh? Talk's done. No, but let's be serious. MVC is a commonly used design pattern for organising code while building your web apps. Now, we all know code isn't just written once and never modified again. Our apps are always changing and growing. The purpose of MVC is to make your code easier to modify in the future. The pattern divides your code into 3 components. I'm going to take you through them in a slightly different order, so just bear with me. The C in MVC stands for controller. Controllers manage your web application's HTTP requests. The M stands for model. Models are typically where your domain or business logic lives. And the V stands for view. This is where you'll find all of your display logic, telling the page how things will actually look. This is where your HTML, CSS, and JavaScript are going to live. How many people have seen this before? Yeah? A couple? You probably see it in a vertical line rather than horizontal. But this is the directory structure for a standard Rails app. This is what you see when you generate Rails new. The Rails apps by default, they're set up to follow the MVC pattern. Some of the directories include controllers, just like I mentioned, where the logic lives for HTTP interactions. Models, which house your domain logic, and views, where display or presentation logic lives. And by putting the right logic in the right place, Rails automatically knows what to do with it. But what does all this mean? A diagram like this is commonly used to describe the pattern. And what you can see here is that when a user, using your browser, sends a request to your web server, the request hits a controller, which finds the information from the appropriate model, sends that data to the appropriate view, and then bundles it all up, back up in a response. And this is what gets displayed in the browser. You all with me so far? No? No? Okay. Fuck that. Let's go shoe shopping. So this Friday, I'm going out for dinner. And, any excuse is a good excuse to go and buy a new outfit. And last weekend, I went out and I bought a new dress. And I bought a pair of shoes to go with them too. Now, do you like my shoes? Yeah? Now, imagine if you went shoe shopping and you walked into a store and found something like this. There's nobody there to greet you. There's nobody there to direct you to what you're looking for or to help you find the shoes that you need or the styles that you like or the sizes that you're after. There's just this big old mess of unlabeled, disorganized boxes everywhere and a pile of shoes, unpaired, disorganized, kind of over there, and somewhere in the corner there's a cobbler sitting there as well, and he's hammering away at his shoes, but he can't help you because he's busy. He's got all these orders to fill. He's got so much responsibility. And you sort of see something over there, looks kind of interesting. So you go over and you pick it out and, oh, red stiletto. It's kind of nice. Size 8, it's my size. Cool. It's the left shoe. Where's the other shoe? You look around and sort of see, on the shelf over there, there's something that sort of looks like, other shoes that are similar to that style. So you go over and you have a look and you see on the shelf there's a box, and you have a look inside the box and you see something that looks like a red stiletto. Cool. So you pull it out and you have a look and you go, oh yeah, same style. Oh, but it's a size 6 and it's also a left. What are you going to do with 2 left shoes, Where's the right shoe? Where's the other half of the pair? You really want to buy these shoes because they're pretty cool and they're going to go with that dress that you just bought. What you could do is spend the next couple of hours hunting through the store, all these boxes and mounds of shoes to try and find the other half. But there's a really good chance that you might not find the other half. In fact, the other half might not even exist in this store. Now just think for a minute. Just imagine if that was how you described your code base. Every day at work, you literally feel like you're trapped in a horror movie. Well, the good news is that back in the 1980s, developers realized that there was a problem with the way that code was being organized and structured. And apart from anything else, it was very hard to navigate and make sense of. So now, I don't know how passionate you guys are about shoes, but in my apartment, the only thing that's perfectly organised is my shoes. So I like an organised shoe rack, just the way I like clean code. Pairs all neatly lined up, left and right coordinated together, evenly spaced, similar styles grouped together. It's clear to see what's there. And something I actually want to look at. Back to shopping. So, the store I actually went to last Saturday, they had a much better strategy for running the show. For starters, they employed a shop attendant whose job is to greet you at the door and help you find what you're looking for. The shop attendant is kind of like a controller. And this time, when you go to buy new shoes, the first thing that happens when you open the door and you make a request to come in, the shop attendant graciously responds to that request with a, yeah, come in, what can I help you with? You look around and you see shelves and cabinets and displays all neatly arranged. Different colours grouped together, different styles over there. You notice something interesting. All of the shoes that are on display, they're all left shoes and they're all size 6. But you don't think anything of it. What you have just been exposed to is a view or a number of views. They are merely a representation of what is actually available to purchase. So, like I said, I went shopping on Saturday because, dinner Friday. And I found what I thought was the perfect pair of shoes. So I asked the shop attendant, can I try those on in a size 8? What I did, I made a request. The shop attendant, or the controller, said to me, hold on just a minute. I'm just going to check and see what sizes I have in the storeroom. So it looks like we've got a bit of time to kill here. Let's talk about the storeroom for a minute. The storeroom houses key information about the store and is the heart of the whole operation. It knows how many shoes are on hand, what sizes, what colours and what styles they are. And the storeroom is kind of like a model. It's the source of truth, providing information about what's on hand. After a few minutes checking out the storeroom, shop attendant came back to me and disappointingly, the shoes I asked for, they didn't have any of my size. But there was an alternative. All of a sudden, I was redirected to a slightly different version that was available in a size 8. What the shop attendant just did, she handled my request, finding out what's available in the storeroom and presenting the options to me. So that was last Saturday. But I was a little bit undecided about the shoes, and to be honest, I've got far too many shoes in my closet that never get worn anyway. So I went home and slept on it overnight. And like shopping for anything, if you wake up in the morning and you know that you still want them, you should go back and get them. So on Sunday, I went back to the shoe store, only to find all of the displays had been completely rearranged. Like, completely rearranged overnight, just like that. Obviously, I couldn't see the shoes that I was looking for anymore, but I could still see the shop attendant. So I asked her. She directed me to aisle 2, third shelf up. Even though the store had been completely rearranged, the controller still knew exactly how to handle my request and which view to direct me to. I picked out the shoes and I headed over to the counter, and the shop attendant gave me some options. I could choose to take my shoes in a box, or leave the box, just take them in a bag, or I could walk out of the shop wearing the shoes on my feet. This one model had a number of views available to it. And you can really only choose one at a time. And these weren't really day shoes, so I just took them in the bag. All right, so what have we learned so far about how the shop attendant, the storeroom, and all the various displays interact? Remember when I asked the shop attendant to try on a pair of shoes in a size 8? She had to go to the storeroom to check what was available and came back presenting the options to me. The shop attendant is like a controller handling all your requests. And do you remember when I first went into the store and only saw size 6 shoes on display? A view is simply a representation of what's in your model. And when I finally bought the shoes, I was offered options on how to take them home with me. That's because one model can be represented by many views. After thinking about whether the shoes I picked out were right and going back to the store to find everything had been completely rearranged, well, the layout of the store had been modified, right? But there was no impact on the shop attendant's ability to direct me to what I was actually looking for. And there was certainly no impact on how the extra shoes in the storeroom were being stored. Because these components have separate responsibilities, it's very easy to make modifications in the shop without affecting the behaviour of other components. Now, this concept is known as loose coupling. If you haven't been around for long, you might hear developers talking about loose coupling or decoupled code, or you're not really 100% sure what that means. But if you remember last Sunday, when I went to find the entire store had been completely rearranged, just imagine how that might have happened. It's only the floor staff who needed to stay back and make those changes. No one in the storeroom or the warehouse needed to know that the store was going to be changed or how it was being changed. And the controller didn't need to know the intricacies, or the shop attendant or the controller didn't need to know the intricacies of how those displays were actually rearranged. Just a quick chat in the morning to say they had been rearranged. Those components, they're so loosely coupled that modifications can be made in one place without having any follow-on effects to the rest of your code. Imagine if every time you wanted to rearrange displays in a shoe store, you also had to rearrange the whole warehouse and hire another shop attendant to replace the one you already have. You'd just avoid making any changes at all costs. So, making code easier to modify. Does MVC solve the problem? Well, the short answer is yeah, it makes your code easier to work with. Splitting code by responsibility means developers know where to look in the code to find, update, or add something new. For example, if they wanted to add a button to gather information from the database and generate a CSV, what they would need to do is add the business logic around collecting and massaging the data into the model. They would then need to add a button in one of the views and decide there what color and shape and size it was going to be. And they would need to add code in a controller to actually output the CSV. It's clear to all developers, new and old on a project, where in the code base responsibilities belong when a new feature comes in. Low coupling means developers know that when they make changes in one area of the code base, it has little or no impact on other areas. So imagine again, those developers wanted to change the information that was generated in that CSV. They could make changes in the model without needing any changes in the controller or view to make that happen. Basically, changing the way one piece of code works in one place doesn't affect another piece of code somewhere else. So, downfalls. Does the MVC pattern have any downfalls? Because obviously I've talked it up a lot. Well, the introduction of a new paradigm adds an additional layer of abstraction to your code. And not only do things become more complex over time, but larger code bases can actually become harder to navigate if you're not careful. In the MVC architecture, you need to understand more moving parts. To keep up with demand today, developers working on code bases that implement this pattern need to have more knowledge across a wider range of technologies. You need to be able to easily work in the front end and the back end and everything in between. And because of feature decomposition, developers now need to maintain multiple representations of the same concept. Remember back at the shoe store? The storeroom, the shop attendant, and the display case all knew about different representations of the same shoe that I was looking for. Whether it was a size 6 shoe on display when I first walked in, or the extra sizes in the storeroom that I never saw, or the shop attendant who just knew where to find everything and finally send me off with shoes in a bag. Some representation of that shoe needs to be maintained to some extent in all of those places. So, hopefully I've done better on my round 2. You guys who thought you already knew MVC, well, you should have a pretty solid grasp now, I hope. And anyone who's newer to programming, you should be able to take this analogy and apply it to something you're passionate about. Thanks everyone, and hope you all enjoyed.